This video will go through two worked examples on how to calculate the molarity of a solution. In the first example, we have 17.54 grams of barium hydroxide, and that's going to be dissolved in water and made up to 500 mils in a volumetric flask. So we need to determine the molarity. Now remember that the equation for molarity is moles, let me get my pen on, is moles over volume in litres. So in this case, we have 500 mils. So remember, we need it in litres. So how do we start this equation? Very first thing, we need to determine our molar mass of our barium hydroxide. So remembering our symbols for barium hydroxide, OH2. So when we calculate the molar mass, our barium is 137.3, and we want to add 2 hydroxides, and inside hydroxide we have 1 oxygen at 16, and we have 1 hydrogen at 1. So when we plug this into our calculator, we'll get a molar mass of 171.3 grams per mole. Okay, so that's of our complete barium hydroxide, but we only used 17.54 grams of that. So we want to find out how many moles of barium hydroxide did we actually use. So I'll put that over here, barium hydroxide used. So to figure out that, that's pretty simple. We just plug our mass in, so that was the 17.54. Put that over our molecular mass at 171.3, and we'll find out that we used 0.1024 moles of barium hydroxide in this solution. So now we've got the number of moles, we have our volume in our litres. Remember, it's 500 mils, so we want it in litres. So remember, 0.5. So now let's plug it in. So we have our moles at 0.1024, and we put that over our volume of 0.5, and that gives us our molarity of 0.2048 moles per litre. Now, just a note on significant figures here. I've given it in more than you need. The equation has put it to 2 decimal places, so I also would give the answer in 2 decimal places so that you would round up, so you'd have 0.21, and that would be completely acceptable. In our second example, what mass of pure sulfuric acid must be dissolved in water and made up to 250 mils to make a 0.55 mole per litre solution? So in this case, we're changing the equation around a little. We already know our molarity, and we know our volume. It's in mils, so obviously we need to change that to litres. But we want to find out what the mass is. So we're going to flip our equation a little bit, and we're going to go to the number of moles of solute. So we want moles, that's what we want to find out. And we already know that that's going to be equal to our molarity times our volume. So we'll just keep that equation up there. Now remember, the first step in all these equations is to determine our molecular mass, and in this case it's a molecular mass of our sulfuric acid. So we're going to have 2 hydrogens at 1, and we've got our sulfur at 32.1, and we have 4 oxygens at 16, and that's going to give us a total molecular mass of 98.1 grams per mole. Let's use our equation now to determine the number of moles that was actually used. So I'm going to go back to the red. So we want to find out our moles. We know our molarity, and our molarity was 0.550, and we want to times that by the volume, and that's our 250 mils. Remember, it needs to be to the litre, so that's 0.250, and that's going to give us the number of moles of, let me just quickly do that in the calculator, 0.138. So that's the number of moles that we have. Now we actually want to go back to the question. We're looking at the mass of the pure sulfuric acid. So we have the number of moles now. So to find out what the mass is, we take our number of moles. Let me just change color. We change, so let me go mass is going to be equal to the number of moles, so 0.138. We want to times that by our molecular mass here, so 98.1, and that's going to give us, rounding up a bit, 13.5 grams. So now that you've worked through these two examples, go back online and try the exercises on your own.